So 5.1 is about the unit circle. The unit circle is kind of the basis for the stuff from here on out, okay? So we're doing a lot of trig stuff this second semester, or the second term, I should say. So in trig, we use a circle with center at the origin and radius of 1 to help us define the trig functions. In this section, we're going to review the properties of the circle and points on the circle. So unit circle means it's 1 unit out, okay? Centered at 0, 0, so this is what it looks like. The equation for that circle then would be x squared plus y squared equals 1, correct? Okay, so that's what we're going to be using for these first problems here. It says a point xy is on the unit circle only if it fits in this equation. So it says here the point is on the unit circle because if I plug this in for my x, whoops. If I plug square root of 3 over 2 in for x, don't I get square root of 3 over 2 squared because that's my x squared? And if I plug a half in for y, don't I get a half squared there? What happens when I square the square root of 3 over 2? It turns into 3 over 4. So that's where this 3/4 comes from. If I square a half, I get 1/4, and doesn't that equal 1? Yeah. So as long as that turns out to be 1, it is on the unit circle. Okay, so some of your questions will be pretty straightforward like that. Determine whether it's on there, just plug them in and see if it works. Let's try this example. Okay, the point x comma 1/4 is on the unit circle in the second quadrant. What is the value of x? So we're just going to start with the generic equation. X squared plus y squared equals 1. And what am I going to plug in? 1/4 in for y. So I'll plug 1/4 in for y. What's 1/4 squared? 1/16. So I have x squared plus 1/16 is equal to 1. Then how do I get the x squared by itself? Subtract 1/16 over. So if I subtract 1/16, I get x squared equals what? 15/16. Next step, square root. So if I square root, I get x equals plus or minus square root of 15/16. And what one of those can make it out? Close. Square root of 15, does that come out at all? 15 is 3 times 5, right? So nothing comes out of the square root up there. So it's just square root of 15. And the denominator turns into 4 if I take it out. Now I have to determine whether the positive or negative is the one that I want. So if it's in the second quadrant, here's my first quadrant. You might just want to write these in case you need to. We'll be using the quadrants a lot. And this is the fourth. So if it's in the second quadrant, is the x positive or negative? Negative, because it's to the left, right? So my answer here would be, what is the value of x? X equals negative square root of 15 over 4. Questions there? So terminal points on the unit circle, it's actually a point on the unit circle, okay? So suppose t is a real number. Let's mark off a distance t along the unit circle starting at the point 1, 0. So you always start over here. This is the starting point of the unit circle. And you move counterclockwise if it's positive. So we're always moving counterclockwise. If it's negative, then what do? We move the opposite direction. So if it's negative, that's when you move clockwise, okay? But typically we're moving counterclockwise because typically our value is positive, okay? So you're starting here, moving counterclockwise. It's kind of a key there. Okay, the point is called the terminal point, determined by the real number t. Okay, circumference of a circle, if you remember back to whatever grade this was in, probably 4th grade, circumference is 2 pi r. What's the radius of our circle? Of our unit circle? 1. So isn't the circumference just 2 pi for this circle? So if we go all the way around, we get to 2 pi. So if I start here, I'm just at 0 because this is my starting point. If I go all the way around the circle, I'm over here at 2 pi now. So if I go halfway around the circle, where am I at? Pi. So maybe mark these on here. So this is starting at 0. If I go halfway around, I'm at pi. If I go the other half, I'm over here at 2 pi. So this is 0 and 2 pi. What if I go up to here? How far have I gone? A half a pi, or pi over 2 is what it's more typically called. What if I go down to here? 3 pi over 2. This is like a half pi, 1 pi, 1 and a half would be 3 pi over 2, and then 2 pi. So those are the key points on the unit circle. There's obviously, a bunch of points in between as well, which we'll talk about on the next page. But let's go ahead and find the terminal points for the following distances. So if I go pi around, don't I land right here? What's that coordinate point called? What's my x coordinate? -1, right? Because it's a unit circle. So this would be -1, comma, 0. So that's what I'm putting here. That's the terminal point. I'm going to allow you a chance to try these. All right, if I'm trying to do pi over 2 is up here. So if I go pi over 2 around, it lands right here. And it's a unit circle. My x is 0, and my y is up 1 unit. So this would be 0, comma 1. So a lot of people had that one, right? 3 pi over 2 is down here. So what would the coordinates be down here? 0, -1. -pi over 2. Yeah, instead of going counterclockwise, I'm going clockwise. So if I go clockwise pi over 2, where does it land? It lands right here, doesn't it? Okay, so -pi over 2 lands at the coordinates 0, -1 again. So maybe try these other couple now. All right, so if I go -pi would be pi this direction. Doesn't it land the same spot as +pi? So it'd be -1, comma 0. Okay, so -pi would be going clockwise pi, right? And if I go clockwise 2 pi, wouldn't that be all the way back around? So what do we get for -3 pi over 2? 0, 1. Okay, because -3 pi over 2, I go clockwise 3 pi over 2, so I end up here at 0, 1. All right, this page here, we're just going to fill in some stuff so we can find our unit circle. All right, there are some very key points on the unit circle that aren't at those 4 points that we talked about on the last page, like to the right, left, up, and down. There's spots that are in between that are really key. So one of the spots in between is halfway in between. So I kind of marked that on your paper here. Now, if it's halfway in between, what's true about this length and this length? They're going to be equal. So if I call this x, isn't this also x? And what's the length of the radius for the unit circle? 1. So can't I find what these coordinates are using Pythagorean theorem? Okay, this is how you can determine it. Once we have it determined, you're going to memorize these, okay, because these ones are the key ones on this page. So Pythagorean theorem, I would do x squared plus x squared equals 1. What's x squared plus x squared give me? 2x squared. So I have 2x squared equals 1. Then what? Divide by 2. So I get x squared equals 1/2. And then square root it. So I get x equals plus or minus. And square root of 1/2 is square root of 1, which is 1 over square root of 2. And then I'm going to rationalize the denominator. So if I don't want the square root down here, what do? Multiply by square root of 2 over square root of 2? Yeah, sure. So in the numerator, I just get square root of 2. What do I get in the denominator? 2. Okay, this is where it comes from. I solved for what the x is and the y is. Oh, from here to here, I just rationalized the denominator. So if you have a square root in the denominator, you just multiply by itself, because square root of 2 times square root of 2 gives me 2. So you don't want a square root in the denominator. You did a lot of that in like algebra 2. Okay? So we end up with square root of 2 over 2. So the coordinates of this point are what? Square root of 2 over 2, comma, square root of 2 over 2. That one's pretty easy to memorize. You're just going to memorize that, so are you going to have to do this work every time? No. Because you see how the x and the y are the exact same? Okay. To figure out the bottom ones, this is like a third of the way through this chunk of the unit circle, and this is 2/3 of the way. Okay, those are the other two key spots. So if I go a third of the way, isn't this whole thing 90 degrees? So if I go a third of the way, how many degrees is this? 30, right? So wouldn't this whole angle here be 60 degrees? Okay, if this here is 30 degrees, and this is 90, how many degrees is this one? 60. So I've got a 60, a 60, and a 60 total over here, right? So what kind of a triangle is this that I drew? It's an equilateral. All the angles are the same, so all the sides are the same. What is the length from here to here? What's the length from here to here? 1. So what's the length from here to here of this whole side? 1. So from here to here is a half. So can I find what this length is if I need to? Yes. So let's find what x is there. So let's use our Pythagorean theorem. How would I set that up? X squared plus a half squared is equal to 1 squared, or just 1. Okay, and then we're going to solve this for x. So I have x squared plus 1/4 equals 1. What do I get if I subtract the 4th over? 3/4. And what do I do from there? Square root it. Square root of 3/4 is the same thing as what? Square root of 3 over 2. So what are the coordinates of this point here? What's the x? What was my x? Square root of 3 over 2. And what is my y? What was my height? A half. So square root of 3 over 2, comma 1/2 is there. Now this one we could do a really similar way. This is actually going to be a similar triangle to what I have down there. If I cut this so it's 2/3 of the way, wouldn't this be my 60-degree angle? And then I could cut this straight down, and this would be my 30-degree angle up here. So do you see how that's the same triangle as this one here, except for it's flipped? The 60-degree is down here, and the 30 degrees up there. So now the length across the bottom is going to be a half. And the length up the side would be the square root of 3 over 2. Okay, those just flip for this one. Because they're going to be on our unit circle that we're going to use a lot, like for all these sections. Okay. Okay, we're going to try to find the terminal point for 13 pi over 6. So is 13 pi over 6 any of these main points right here? No, but what I have to do is figure out where 13 pi over 6 lies on my unit circle, okay? So when I'm doing this, pi over 6 is right here, isn't it? A third of the way? Does everyone see that? So that's 1 pi over 6 is right here. Isn't 2 pi over 6 right here at pi over 3? Think of 2 pi over 6. Wouldn't that reduce to pi over 3? Where is 3 pi over 6 at? Right here, isn't it? Okay, so I cut it a third of the way. I went, this is 1, 2, and 3 pi over 6. How many do I need total? 13. So this would be 4, 5, 6, wouldn't it? What would be down here? 7, 8, 9, 10, 11, 12. So 13 pi over 6 is actually the same as pi over 6. Do you see that? So what is the terminal point for that? Square root of 3 over 2, comma, 1/2. For these, they're going to land on one of the spots on your unit circle. And that's a coordinate point, so you put parentheses around it there. You don't have to count. That's just one way to do it. I find that people can typically do that, okay? The other way to do it, 13 pi over 6, isn't 12 pi over 6 the same as 2 pi? Isn't that one full revolution or one full rotation there? And isn't 12 pi over 6 plus 1 pi over 6 equal to 13 pi over 6? And this gets us back to the start, so you can kind of ignore it, can't you? So do you see how it's going to be the same as just pi over 6? So you can use this method too if you want to, whichever you find easier, okay? All right, the next piece here, find the terminal point for negative 17 pi over 4. So where is pi over 4 at? Pi over 4 is halfway, and if we're talking negative, it's halfway down here, isn't it? So you start here, but if we do 17, wouldn't it be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wouldn't 17 be right here? Okay, or if we do it this way here, let's try it this way. Okay, negative 17 pi over 4, isn't that negative 16 pi over 4? Plus negative pi over 4? Wouldn't that be negative 17 pi over 4 total? And isn't this negative 4 pi? Which is negative 2 pi and another negative 2 pi. So it's like rotating around 2 times and then going another negative pi over 4. So now we have to figure out what this terminal point is down here. So we've determined it's down here. Pi over 4 is up here at square root of 2 over 2, square root of 2 over 2. If I'm down in the fourth quadrant, is my x-coordinate positive or negative? Positive. So it's still going to be positive square root of 2 over 2. Is my y-coordinate positive or negative if it's down in the fourth quadrant? Negative. So that's the only way that that differs. So the terminal point would actually be this right here. So questions there? Let's fill in our unit circle. Okay, so let's fill in the easy points here. At 2 pi, what are the coordinates here at 2 pi, or at 0? The coordinates are 1, 0. Be careful not to mix your x and y up. People do that and don't get points for the easy ones here. Okay, what's the top point here going to be? 0, 1. The angle measure, I think I give you the angle measures on there. Okay. Over at pi, it's negative 1, 0. And down at 3 pi over 2, it's 0, negative 1. So those aren't too bad. How about at pi over 4? Square root of 2 over 2, comma, square root of 2 over 2. So let's do all of those spots now. So if this one's positive and positive, we said this one here at 7 pi over 4 is going to be what? Positive, negative. What about in the second quadrant? What's this one going to be? 3 pi over 4. Negative, then positive. The x is negative, and the y is positive. And how about in the third quadrant? Negative, negative. Questions there? Okay, if you need to refer back, what is it at pi over 6? square root of 3 over 2, comma, 1/2. And now you just have to be careful that you reflect this correctly. If I reflect this down, which spot am I talking about? 11 pi over 6, right? This goes down right to here. So the x is still positive, but the y is going to be negative 1/2. Everyone see that? If I reflect it over the y-axis, it's going to land here at 5 pi over 6. So that's going to be negative and then positive. And if I reflect this down into the third quadrant, they're both negative. So questions there? Okay, so we've still got pi over 3, which is 1/2, comma, square root of 3 over 2. And if I reflect that down, it should be positive, negative. If I reflect it across, it's negative, positive. And if I reflect that down, they're both negative. And then just be careful when you're done with this. Check to make sure everything in the first quadrant is positive. So check your paper because you're going to be using this unit circle a lot. Okay, over in the second quadrant, the x should be negative and the y should be positive. So make sure that's true on your paper. When you get down to the third quadrant, everything should be negative. And in the fourth quadrant, it should go positive and negative. So go ahead and check that, make sure that that's true for all of yours. All right, reference number. Notice this says number, not point, okay? So we should end up with a number for this. Is pi over 3 a number? Yes, okay? But we don't want a coordinate for this is what I'm saying, okay? So when it says reference number, it's the shortest distance along the unit circle between the terminal point determined by t and the x-axis. That might sound confusing. I'll show you how to do it here. Okay, so let's just look at the first example. First example says find the reference number and the terminal point for t equals 2 pi over 3. So it does say to find both, so let's try both here. All right, to find the reference number, let's first find where 2 pi over 3 is on my unit circle. So you have your unit circle right above there, right? Where is 2 pi over 3 on that unit circle? Which quadrant? In the second quadrant, and it's up here, isn't it? So the reference number is the distance from here to here. So what would be the distance from here to here to get to this t value? Pi over 3. So my t bar is pi over 3. And I'll show you how I got there if you're confused. Okay, isn't this 2 pi over 3 to get from here to here? Wouldn't I need pi over 3 more to get down to here? If I added those together, wouldn't I end up at pi? If I had 2 pi over 3 plus pi over 3, that would give me pi total, which would get me to here. So you're trying to get to the x-axis, so it's this distance from here to the x-axis. Sure. Or let's try this one, and then if I need to, I'll go back, okay? So let's try this one doing the reference number. So I've got 5 pi over 4, just wait quick. Okay, 5 pi over 4, where's 5 pi over 4 located? In the third quadrant. So where in the third quadrant? Halfway. So here's where my t is. And I'm trying to find the distance between the x-axis and that point. So how far is it from here to here? Pi over 4. So that would be my t bar here, would be pi over 4. Okay, so it's always positive. You don't have to worry about negatives here because it's a distance. So the last one here is at negative 5 pi over 6. Now here it might be harder with your unit circle, but if I'm doing negative 5 pi over 6, let's look at this here. Isn't 5 pi over 6 here? And that would be if I was starting here and going counterclockwise. So if I start here and go clockwise the same distance, wouldn't that be right here? Okay, so that's where we're talking about. So what's the distance from here to here? Pi over 6. And you can see that because in the first quadrant, you see how it's pi over 6 there? So that actually gives you kind of the numbers there if that helps you. Okay, so let's just mark it on our picture here. So on our picture, it would be the closer one here, and the distance from here to t would be pi over 6. Yep, you can find where it is positive and then just match it going the other direction, okay? All right, so it said find the reference number, so we found that. And the terminal point, if we needed the terminal point, couldn't we just pull them right off of our unit circle? Okay, so this spot here at 2 pi over 3, looking on your unit circle is negative a half, comma, positive square root of 3 over 2. So do you see how easy it is to do the terminal point if you know that unit circle? Okay. And if you need to do the rest of them, you can find those also. Okay. There's your homework assignment.